This video is sponsored by PCBWay.
So it's winter right now and I've been craving a new project, so I decided to make a snowblower but on an RC car.
And I was going to make a single stage snowblower, where the auger picks up the snow and throws it out through the chute in one single motion. A two-stage snowblower works in two steps. First the auger in the front picks up the snow, then a second part called the impeller throws the snow out through the chute. But that is just too complicated.
So here's what I've come up with.
We will need some parts though, so I went and got myself roller bearings for the auger to spin freely, and a new battery for the motor, and screws for attaching the auger to the car. Then I started with a checklist, and my snowblower design can be broken down in two different parts. The auger is the spinning part at the front of the snowblower. Its job is to grab the snow and put it inside a machine, and the biggest part is the frame. It's responsible for attaching everything, and it needs to have a way to mount the auger and motor, and it got to have a chute for the snow to get out and a mounting point for the RC car. So I got to designing. So the first thing I got into was the auger, and I made it with Fusion 360, but there's no helix tool which I needed for the auger, so I tried downloading some helix generator tool off of GitHub. But I couldn't get that to work. Therefore I had to export it to Onshape and actually make the helix, which worked great, so shout out Onshape. And with the finishing touches, it's done. Next I moved on to the frame. First sketched out the shape and dimensions, then extruded it. After that I created the hole where the bearings would go. I also needed to make sure that it fit, so I made some test prints. And after some generations, it fit perfectly. However, I quickly ran into a problem. There was really no way to fit the auger into the frame once it was fully modeled. Other RC snowblower designs usually solve this by splitting the auger into two different parts. The shaft and the blade, which are screwed together afterwards. But I felt that that approach would be too complicated for me to create. So after some brainstorming, I came up with another solution. I was going to split the frame itself into two parts and then assemble it later. I added tab and slot connections so the parts align and hold together better. So I printed it out to test, and it worked pretty good. But with some slight fitment changes, it was perfect. And with that, we can check the auger mounting. Up next was the chute, and it was pretty easy to make. First I made a hole in the frame. After that I created the form and used the loft tool to shape it. Then I used sweep to extend the design along the path. Next I extruded the part and finished the chute by adding fillets and chambers to smoothen and refine the edges in Autodesk Fusion 360. Now on to the mounting bracket. First I came up with a design. I needed all the measurements of the shock absorber mount, and after that I used a technique where I took a picture of the car and imported it to CAD. Then added the measurements to get an accurate model of the complex shape. I made a test print, but it didn't fit, so I adjusted the design and tried again. Several times. And after 5 iterations, it finally fit perfectly. Then I molded up and printed the final mounting bracket. So now I'm done with that. Wrong! The thing is that the mounting bracket was in an angle because of the differential housing had been damaged in an earlier crash. So I had to disassemble the entire front of the car, replace the old diff housing with a new upgraded metal one, and then reassemble everything. And after that, we can check it off. So the last thing to make is the motor mounting, that didn't take so much time to make. I just made a sketch, measured the motor and used the screws that came with the motor to make the design in CAD and print it. I took it all into the final design, and with that we can check both the motor mount and frame. So now, after all my efforts, it's finally time to export the project and actually hit print.
only other big thing I've printed is this glow box, which I made in my previous video.
Then I started printing the other parts. But this print failed due to the support, so I changed the threshold angle to 45 and type to normal. And with that, it works.
Now to the satisfying part. Then we'll need to assemble it.
But the auger didn't fit, so I changed the model and reprinted. So now we can assemble it.
But wait, how are we going to make the auger spin? Well, with gears.
And I used Onshape's gear tool to make it happen. I just needed to insert the number of teeth and thickness and we are done.
Okay, so if I plug in the battery right now, all of this should start working or spinning. So I just hope it does. Oh! Yes! Oh my god! Oh my fucking... Oh my god, it actually works! That's so cool. Wow. I'm so proud. Yes. But obviously I can't drive like this because the big gear hits
The table.
But I also changed the design of the frame, so I'll need to reprint that.
I also wanted to print this out in blue. But there was still one problem, the motor didn't fit. But I quickly solved it by filing and sanding it away.
Plugging in the battery.
Oh, wait! I can feel air getting pushed out of this hole. Oh, that's insane!
I think it's gonna work. Now I can actually drive the thing.
But there's still a problem.
The gears are made out of PLA, which isn't that strong.
And that's because PLA isn't that durable, but I still use it because it's easy to print with. ABS on the other hand is harder to print with, but it's durable and impact resistant. With high heat and water resistance, PLA is hard and stiff. Both materials are cheap. PLA is suitable for prototypes and decorative items, while ABS is suitable for functional and mechanical parts. But I don't have any ABS filament, and that is why I will be using PCBWay, the sponsor of this video.
So PCBWay offers CNC machining, which I think is really cool, 3D printing, sheet metal fabrication, injection molding, PCB assembly, PCB design, and I am going to 3D printing, dropping in my files, setting ABS as the material, changing the color to black, and here you can type any special request you have. It will tell you the subtotal and shipping time. Then just submit request.
And 7 days later we got the package. So let's unbox it. PCBWay stickers. And here they are. They feel more solid. Let's test them out. Out with the old, in with the new.
And with that, it's finally done. I can't believe how great this turned out. At many points, I questioned myself and wanted to give up, but I kept going. But unfortunately, there's no snow outside. But that doesn't mean I'm not going to test it.
So I asked Gemini, and by far the best was mashed potato powder, and coconut because it looks like snow.
So I also bought some oat milk because it's cheap. So let's try it out.
Bro, this is heavy. I don't know if it's gonna work, but let's try. Okay.
Okay, so it kind of worked. I will say oatmeal is heavier and denser than snow, so that's a factor. Okay, now to the mashed potato powder.
Okay. Ooh. Okay, I'll say that worked out pretty good. This was a more realistic test because of the consistency. This is really soft. It's actually really similar to snow.
Okay, now to the coconut. That looks most like snow.
Oh, det smelter så godt.
Oh, PLA gears can't do that. This worked out great.
And if there's one thing I want you to take from this video, is to never give up. Keep challenging yourself. I also uploaded all the files to Cults, and right now they're on a 50% discount. So if you have enjoyed this video and want to support me, like and subscribe, press the hype button if you're on mobile, and check out my link to PCBWay. Goodbye.